Hello everyone and welcome back to my channel and welcome back to today's new video. So in this video I have got Newton's first law of motion and inertia. This is going to be a 4-part series where I introduce Newton's first 4 laws of motion, and then in the next 4 parts I'll be doing the mathematics behind them and showing you guys how the mathematics incorporates into this particular section in physics. Now here, I just want to introduce the theory behind it, and I want you guys to get familiar with the terms and how the law essentially works. So, in Newton's first law states that an object will remain at rest or move in constant velocity unless acted upon by an unbalanced or an external force. When we say an object moves at constant velocity or it remains at rest, what that basically means is that the net force on the object is 0 newtons. Whenever it's at F net equals 0 newtons. That is the net force of the object. Now, whenever we say an object is at rest, we look at the two forces that are present there. That is going to be the normal force and the weight or the gravitational force. So what we have is we have an object sitting on a smooth surface. Now there are two forces present and they're acting antagonistically towards each other. Now we've got the normal force, which is acting up, that is coming from the table, pushing the object up, and there's the gravitational force, which is essentially holding the object to the ground. Now if you were to draw the free body diagram, it'd be like this. Please just use a ruler, and then you would say Fn for normal force, and then weight, or Fg for gravitational force. This is what the free body diagram would look like. Now, when I do the mathematics, I'm going to show you guys how to incorporate these two into mathematics and how you can actually solve mathematics-based problems. It's also worth noting that the amount of force is equal. The normal force is equal to the weight force, and we know that weight or gravity is 9.8 meters per second squared. That also means that the value of the normal force is also going to be 9.8 meters per second squared. Now, you need to understand within Newton is that whenever object acts horizontally or vertically, the amount or the value of the forces, in most cases, I would say 90% of the time, will always be the same, and the values will always be equal. Because when you use this, we can actually incorporate it into working with different angles and working whenever we've got two objects acting on one surface. And what you would have to do now is that you would have to solve the objects simultaneously. The same can also be said whenever an object is moving at constant velocity. So what I have, for example, what I have over here is a ball being shot out of a cannon, and this ball is traveling at 10 meters per second. Now what this basically means is that this ball will continue moving at 10 meters per second unless it comes in contact with an unbalanced or an external force. That unbalanced or external force could be either a wall, the ball will crash into a wall, or it could hit a person, or it could really be influenced by any other factor that would cause the object to move in a different direction, or either it would increase its velocity or slow down its velocity. In instances like this, air friction is usually ignored whenever we deal with this type of scenario, because what air friction does is that it really complicates everything. And remember, with friction, what we find is that friction typically slows the object down. If an object is moving in a particular direction, the friction would be acting in the opposite direction, and that would quote unquote try and slow the object down. Hence why we ignore it over here, because we're dealing with one theory over here to say that the object will move at constant velocity. When it's moving at constant velocity, the net force is also equal to 0 in this instance. Now with inertia typically states that the tendency of an object to resist a change in motion unless acted upon by an unbalanced force. So it's the same thing in these two scenarios. The object is at rest, and that is basically telling us that the object will remain at rest, and it will continue to remain at rest unless an external or an unbalanced force from the outside is acted upon the object. Same thing with the ball and the cannon. The ball will continue to move in this particular direction of motion unless it is acted upon by an unbalanced or an external force, and the ball in itself will not resist or essentially just move by itself. It needs to be acted upon by an unbalanced force. So I hope you guys have enjoyed this video. If you guys have any questions, you're more than welcome to leave them in the comments. Please like, comment, subscribe, and share. and I'll see you guys in part 2. Goodbye, everyone, and have a lovely day.